What's up everyone, welcome back to my channel. Today we're going to work on the weights. I guess it will be very easy for you guys, right? Just the integral of 1 over x dx. I guess most of the calculus students or people who have already taken first calculus course will actually know what the answer is. It's just ln of x, right? Of course, we actually need to put the absolute value inside of the ln outside of x, and don't forget we need to put the constant term plus c at the end, right? It's very easy. So today, of course, we're not going to do such easy integral. We're going to do the absolute value version of it. In other words, we're going to make it into a modulus function of 1 over x. Now, of course, we will just try to split it into two different cases to try to figure out what the antiderivative of this this function is. But splitting into two cases is fairly easy. Our final goal is again trying to put the two different expressions back together and see if we can just use one expression to include all possible cases. Okay. Before we move on, you can actually pause the video and try yourself first. Are you guys ready? Here we go. So, of course, we can actually try to think it into two different cases. This integral or antiderivative, as I said, I like to call it that way, can be split into two possible ways, which is for the antiderivative of 1 over x dx, and you can think that this is actually for x is greater than 0 here in some sense, and then it will turn into negative x 1 over x dx for x is negative. And again, that's actually kind of fair, because when we think of the absolute value of something, we actually change the sign or we'll always keep it as positive, meaning that we will need to change the sign if the original thing is negative. So in this case, when x is less than 0, when x is negative, we will actually get 1 over negative, which is negative. So in order to fix it, we need to put a negative sign in front. Good. So as we try to integrate both terms individually, we'll of course get ln of absolute value, don't forget, of x plus c, some constant, for x is greater than 0. And we will have, of course, we can factor the negative or take out the negative before we take the integral or antiderivative and get negative ln of absolute value of x. Then we have plus c for x is less than 0. Okay, so how are we supposed to combine these two together? Well, we see that the c is, of course, in common, and again, that is just any arbitrary constant. So we know that when we combine those two together, we will still have the c in any general form. But the question is, for the first part, ln of x, we see that is in common. We have ln of x here. Now, how can we actually get the sign correctly without actually splitting into cases? Well, here's the deal. Since, first of all, x cannot be equal to 0, or we can only have x as either positive or negative, we do not have to worry about divide by x, because once again, we're never going to divide by 0 in any case. So we can just say that the positive sign, in other words, is just equal to x over x on top, because we actually can get x over x is equal to 1. Now, how should we fix the bottom part, which actually gives us a negative? What are we supposed to do? What are we supposed to do? We cannot just simply get x over x, right? Now, how can we change that part? Let's put the plus c here first. So in other words, on top, we actually have the plus sign or positive sign, which actually matches with the sign of the x value. Sometimes you actually see textbooks using this. Old school textbooks might actually use this as a symbol And then here on the bottom, we also can use this special function to match it up, because this has a negative sign which actually matches up the sign of the x value. Now, how can we try to avoid using this symbol? Or is there any better way of trying to rewrite this function into something that we are actually more commonly use? Well, here is actually a more common way of expressing it, which is absolute value of x divided by x. Of course, we have to exclude x is equal to 0 case here, because there is no positive or negative sign for x equals 0 in this case. But we don't have to worry about it based on the condition. And if we try to check the right hand side, since the top part has an absolute sign, it's always providing us a positive value. And for the bottom, we have x, which actually depends on the sign of x itself. So you can just think that this is actually going to work, because when x is positive, absolute value of x is just x divided by x, which is actually going to give us 1, or positive 1. Where x is less than 0, is going to provide us negative x on top. And again, because we need to make it into positive, so we have to multiply by -1 to x, which is a negative value, to get double negative, which is a positive. And then divide by the x on the denominator. And again, if we simplify, we get -1, which is the negative sign that we have. And therefore, we can just throw this here into the front to give us absolute value of x divided by x, and then times whatever we have here, n of x, absolute value of x, plus c, to get the general expression of the antiderivative of absolute value of 1 over x with respect to dx. And again, this is just saying that we're trying to get the general expression of the antiderivative of the modulus inverse function in one single line without splitting into any cases. That's it. I hope you all enjoyed this video. Don't forget to like and subscribe to my channel. Also, turn on the notification so that you won't miss any of my new videos. If you have any thoughts or ideas, you can also leave your comments down below. I'll see you guys in the next video.